This Brazilian bird was an absolute behemoth that stood 4.5 feet tall and weighed a whopping 400 pounds. To put that into perspective, Paraphysornis outweighed the largest living bird today, the ostrich. This was no lightweight contender. Paraphysornis was built like a feathered tank, with robust bones that spoke of raw power. Paleontologists believe that Paraphysornis hunted using a combination of kicks, slashes, and powerful jabs with its sharp beak. It's a hunting style that might remind one of a prehistoric version of mixed martial arts, with Paraphysornis as the undefeated heavyweight champion of its time. But Paraphysornis wasn't just a mindless brute. Like many of its terror bird kin, it likely possessed a level of intelligence that set it apart from other contemporary predators. Studies of terror bird brain cases suggest that they had well-developed visual and auditory centers, indicating keen senses that would have made them formidable hunters. As impressive as Paraphysornis was, it was merely setting the stage for what was to come. As we step into the Miocene and Pliocene epochs, spanning from about 23 to 2.5 million years ago, we encounter the true giants of the terror bird family. These were creatures that pushed the boundaries of what it meant to be a bird, reaching sizes that rivaled the predatory dinosaurs of old. Three names stand out in this pantheon of avian terrors: Titanis, Kelenken, and Elurornis. Each of these genera represents the pinnacle of the terror bird lineage, and each had its own claim to fame. Titanis, the youngest and, in some ways, the smallest of the trio, was also the most adventurous. While most terror birds were content to dominate South America, Titanis had grander ambitions. It crossed the newly formed land bridge connecting North and South America during the Great American Interchange, becoming the only large South American predator to successfully establish itself in North America. Unlike most of its relatives, this bird lived in what is now the United States, including the states of Texas, Florida, and California. Standing 6.6 feet tall, Titanis would have been an imposing sight for the mammals of North America. Imagine the shock of a Pleistocene horse or ground sloth, accustomed to watching out for saber-toothed cats and dire wolves, suddenly confronted by this alien predator, half bird, half nightmare. But as impressive as Titanis was, it was dwarfed by its cousins back in South America. Kelenken, named after a mythological Tehuelche spirit, stood a towering 9.8 feet tall and weighed around 550 pounds. This was a bird the size of a grizzly bear, with a head larger than that of a horse, and a beak that could crush bone. Speaking of the terror bird skull. Recent studies have shown that Kelenken and other large terror birds possessed a unique skull structure, setting them apart from their smaller relatives. It's known as the terror bird skull type, and this adaptation gave them increased bite force and pecking power. This suggests to me that these giants may have been capable of taking down larger prey than previously thought. I'm talking potentially some of the megafauna that roamed South America during their reign. But the title of the largest terror bird is still hotly debated, with Elurornis giving Kelenken a run for its money. While slightly shorter at 2.8 meters, or 9.2 feet, Elurornis was built like a feathered bulldozer, potentially weighing up to 400 kilograms, or 880 pounds. This made it not just the heaviest terror bird, but also the heaviest carnivorous bird of all time, and the fourth heaviest bird overall. Interestingly, Brontosaurus has been the subject of scientific controversy. Some paleontologists have questioned whether it was truly a terror bird, or even a carnivore at all, citing similarities in its toe claws to those of herbivorous birds. However, recent studies have identified features in Brontosaurus's vertebrae that are unique to terror birds, lending weight to its classifications as a member of this fearsome family. Whether Brontosaurus was a terror bird or not, its massive size would have made it a force to be reckoned with. Its weight likely made it slower than its more nimble cousins. But what it lacked in speed, it made up for in raw power. I can almost imagine Brontosaurus as the tank of the terror bird world, capable of steamrolling over any prey unfortunate enough to cross its path. While the giant terror birds like Kelenken and Brontosaurus might have relied on their size and power to dominate their environments, many of their relatives took a different approach. Speed, it seems, was just as important as size in the terror bird playbook. Studies of terror bird leg bones have revealed a structure remarkably similar to that of modern-day ostriches. Short thigh bones paired with elongated lower leg and foot bones. This adaptation is a clear indicator of high-speed running ability. Paleontologists estimate that many terror birds, including some of the larger species like Titanis, could have reached speeds exceeding 30 miles per hour, or 48 kilometers per hour. This makes them faster than the fastest recorded human ever, Usain Bolt, while standing twice as tall and weighing several times as much. But speed wasn't just about chasing down prey. For many terror birds, especially the smaller and medium-sized species, it was also a crucial defensive adaptation. In a world filled with other large predators, including giant carnivorous mammals and enormous crocodilians, the ability to make a quick getaway could mean the difference between life and death. This combination of speed and size made terror birds versatile predators, capable of adapting to a variety of hunting strategies. Smaller, faster species might have specialized in chasing down swift prey, like small mammals and reptiles, while the larger, more powerful species could have employed ambush tactics, or even taken on larger, more dangerous quarry. While their imposing size and fearsome beaks often steal the spotlight, the true power of terror birds lay in their highly developed senses. Recent studies of terror bird skulls and brain cases have revealed that these prehistoric predators were equipped with sensory capabilities that put them leagues ahead of many of their contemporaries. While terror birds might not have had eyesight quite as sharp as modern raptors like eagles or hawks, they were far from being visually impaired. Their eyes were well developed and positioned to provide excellent depth perception, a crucial advantage for any predator. But what really set terror bird vision apart was its versatility. These birds were equally adept at seeing in bright daylight and in the dim light of dawn and dusk, making them effective hunters around the clock. As for their hearing, the inner ear structure of terror birds suggests an acute sensitivity to low-frequency sounds. This ability would have allowed them to detect the footsteps and movements of potential prey, even when hidden by dense vegetation. Imagine a terror bird standing motionless in the prehistoric forests of South America, its head cocked slightly to one side. To a casual observer, it might appear to be resting or even dozing. But in reality, every fibre of its being is alert, its incredibly sensitive ears picking up the faintest rustle of leaves or the softest patter of tiny feet. In an instant, it can pinpoint the location of its unsuspecting prey and launch into action. This combination of visual and auditory prowess made terror birds the complete predatory package. It's no wonder these birds were able to dominate their ecosystems for millions of years. But even the mightiest rulers faced their downfall, and the reign of the terror birds was no exception. For millions of years, these avian predators had ruled supreme in South America, developing into a diverse array of species that filled various ecological niches. But somewhere along the line, their luck ran out. Traditionally, the extinction of the terror birds was linked to the Great American Interchange, a major paleozoographic event that occurred about 2.7 million years ago. This event saw the formation of the Isthmus of Panama, creating a land bridge between North and South America. As a result, animals from both continents were able to migrate across this newly formed connection, leading to a significant reshuffling of fauna. The conventional wisdom held that the influx of new predators from North America, including cats, dogs, and bears, outcompeted the terror birds, leading to their eventual extinction. It was a neat and tidy explanation that seemed to make perfect sense. However, as is often the case in science, the truth has turned out to be more complex and nuanced. Recent studies have cast doubt on this simple competition-based extinction model, revealing a more intricate tapestry of factors that led to their demise. The terror birds. The very name evokes a primal fear, doesn't it? I've spent countless hours poring over fossil records, and the story they tell is one of resilience against all odds. For years, I believed they vanished about 1 million years ago, victims of competition from placental predators. But the Earth keeps surprising us. It turns out the story is far more nuanced and perhaps even more tragic. The fossils reveal that most terror birds, along with many of their South American rivals, disappeared long before placental predators arrived in significant numbers. This suggests something else was at play besides just direct competition. And the success of Titanis in North America. That throws another wrench in the they couldn't compete theory. Titanis not only expanded its range northward, but coexisted with large canids and felines for millions of years. Clearly, some terror birds were more than capable of holding their own. So, if not competition alone, what brought about their downfall? Climate change, it seems, played a significant role. The long-term cooling trend from the Oligocene to the Pliocene, culminating in a series of ice ages, would have profoundly impacted their ecosystems. As temperatures dropped, the lush forests that many terror birds relied on gave way to open grasslands. Some adapted, but the larger, more specialized species likely struggled to find enough prey to sustain their massive bodies in these changing environments. The influx of new competitors from North America certainly added pressure, even if it wasn't the primary cause. Despite these challenges, the terror birds were remarkably resilient. Recent discoveries have pushed back their extinction date much further than we previously thought. We now know that some smaller species of terror birds existed as recently as 96,000 years ago. Even more tantalizing is the discovery of fossils attributed to an unidentified terror bird species in a formation dated to just 18,000 years ago. If confirmed, this would mean that terror birds survived almost to the cusp of human arrival in South America, around 15,000 years ago. Imagine that. How close did humans come to encountering these feathered giants? What would such an encounter have been like? Could there be any truth to the legends of giant birds that persist in the folklore of some South American cultures? While direct interaction is unlikely, the possibility that our ancestors heard stories of these creatures passed down through generations isn't entirely far-fetched. After all, other megafauna that coexisted with early humans, like woolly mammoths and giant ground sloths, left lasting impressions on human culture and mythology. Larger males typically weighed upwards of 400 kilograms, making them close contenders for the title of largest felines ever. Judging from the enormous size of these giants, it's easy to assume that tigers have always been this large. However, a look through history tells us something completely different. Tigers haven't always been this big. Early tigers, existing long before the Nyandong tigers, were notably smaller in terms of body size and weight. This smaller stature could be attributed to the available prey and the ecological niches they occupied. A smaller body size offered energy conservation and agility advantages across various terrains. Early big cats related to tigers, such as Panthera paleosinensis, likely averaged around 70 to 120 kg in weight. Following them was the Trinil tiger, popularly believed to be the ancestor of all known Indonesian subspecies. I often find myself wondering about the creatures that truly dominated their time. Imagine being an apex predator, ruling the wild, at the very top of the food chain. Life at the top certainly has its perks, but even the most fearsome hunters aren't always the biggest beasts around. Sometimes nature outdoes itself, creating a carnivore so specialized, so perfectly adapted to hunting big game that it seems almost like a creature of myth. The Ngandong tiger, for instance, gradually increased in size over the years. This can be explained by the intense competition for food among large carnivores. This placed it at a disadvantage in the competition for apex predator status. But that wasn't the only thing the Nyandong tiger had to worry about when defending its title. Around this time, early humans were notably prevalent in Southeast Asia, with over 80 individual remains found in that region today. It's likely that they crossed paths with the Ngandong tiger. It's easy to assume that such encounters would have been unfavorable for the early humans because, when it comes to size, they stood very little chance against such predators. But saying that would be undermining their intelligence. Over time, early humans might have developed tools and strategies to fight back, forcing the tigers back to the open woodlands and allowing early humans to establish a foothold in the region. The open woodlands of Sunderland in the Pleistocene epoch had numerous scattered trees and grasslands, which provided good visibility for stalking prey and offered a diverse array of herbivores, including many large species. However, hunting larger herbivores may not have been that successful, despite the Neandong's enormous size. Stegodons, for instance, were massive proboscideans closely related to elephants, with some species reaching immense sizes. Even smaller species of stegodons would have dwarfed the Gondong tiger. Stegodon donsky, for instance, is estimated to have weighed around 12.7 tons. Their thick and tough skin would have protected them from bites or claws. The Ngandong tiger's best chance would be a scavenging opportunity, or an attack on a vulnerable stegodon, like the young, injured, or isolated. Another example is the water buffalo, known as bubalis, which are renowned for their large size and formidable strength, with some species weighing over 1,000 kg and moving in packs. It would have been quite hard to face a herd of water buffalo, as their massive size, strong horns, and collective defense would overpower the tiger. The Ngandong tiger's only chance against such a colossal opponent would be to exploit their limited agility and target vulnerable areas through a surprise or flank attack. However, the Neandong tiger succeeded more with other herbivores like Rusatamarensis, Malayan tapir, giant rats, gibbons, and wild boars. Despite its many difficulties, the Gondong tiger still earned its place as one of the most impressive predators of all time. Since it hunted alone, its smart hunting skills and ability to target weaker prey, and even sometimes scavenge, shows us how adaptable and tough the beast was. This quality made it thrive for 1,000 years until the extreme climate shifts of the Pleistocene epoch. These included periods of intense cold, with vast ice sheets locking up water, leading to lower sea levels, followed by warmer periods with melting glaciers and rising sea levels. As a result of this, Sunderland was fragmented into smaller islands, leading to isolated populations of Ngandong tigers with limited resources and genetic diversity. From these isolated populations emerged smaller subspecies of tigers, such as the Sumatran tiger, Bali tiger, and Javan tiger. While climate change undoubtedly played a role, scientists propose that the presence of early humans in Southeast Asia might have been among the reasons why the tigers went extinct. They likely caused increased competition for resources or potential conflicts that impacted the Neandong tiger population. Other factors may have also contributed to their demise. But with limited fossil records, we are left with many unanswered questions. I sometimes imagine walking through Brazil 160 years ago and stumbling across a strange set of bones. That's how the story of the Smilodon begins, with a discovery that utterly perplexed the scientific community. The first remains were unearthed, but paleontologists didn't immediately recognize them as belonging to a cat. It's hard to believe, but their initial guess was way off. Based on some isolated cheek teeth that bore an uncanny resemblance to those of modern hyenas, they initially dubbed this new find Hyena neoga. Within a couple of years, though, more fossils came to light. Suddenly, scientists weren't just looking at a few teeth, but a veritable jigsaw puzzle of prehistoric proportions. This group is pretty exclusive, with only 5 known genera calling it home. But what Smiliodontini lacks in diversity, it makes up for in star power, thanks to Smiliodon. As research progressed, scientists discovered that Smiliodon wasn't a lone standout, but more like a prehistoric trio, with 3 distinct members, each bringing something unique to the table: S. gracilis, S. fatalis, and S. populator. Now, if you found yourself face to face with any of these species, you probably wouldn't be too concerned with which one was about to turn you into lunch. But they did have their differences. First up, we have S. gracilis, the elder statesman of the group. This OG appeared in North America about 2.5 million years ago, descending from an even older genus called Meganterion. Next came S. fatalis, strutting onto the scene roughly a million years later. Last, but certainly not least, S. populator made its grand entrance about 600,000 years after fatalis. Fashionably late to the Ice Age party, S. gracilis, while no slouch in the size department, was the runt of the litter, tipping the scales at about the same weight as a modern jaguar. S. fatalis, living up to its name, was a step up in the terror department, matching an African lion in size, but packing on extra muscle like a feline bodybuilder. We're talking about 280 kilos, or 620 pounds, of prehistoric fury. That's on par with the largest tigers roaming the earth today. But S. populator dominated them all. And at the end of those muscular arms, Smilodon was further armed with fully retractable claws, razor-sharp and curved like prehistoric scimitars. They were proportionally enormous, even for a cat of Smilodon's size. We're talking about claws twice the size of a Siberian tiger's. Those impossibly long canines, they've captured imaginations for generations, haven't they? And saber teeth aren't unique to Smilodon, not at all. Nature has played around with this dental design in various mammals, and even some non-mammals, throughout history. But Smilodon perfected it. What made its fangs special wasn't just their presence, but their sheer audacious length. We're talking about canines so long they protruded well beyond the lower jaw, a feature uncommon even among other saber-toothed cats. To put it in perspective, Smilodon's canines could grow up to 8 inches long. That's longer than many modern kitchen knives. Precision instruments of prehistoric destruction, shaped like deadly daggers. You'd expect a predator with teeth like that to have a powerful bite to match. But surprisingly, studies have shown that Smilodon's bite was relatively weak, about 4 times weaker than a modern lion's. So how did it kill? That's been a subject of much debate among paleontologists. One popular theory suggests that Smilodon was the original ambush predator. I can almost picture it, hidden in dense vegetation, waiting for the perfect moment. Then, with a powerful leap, it pounces on its unsuspecting prey. Using those muscular forelimbs and grappling hook claws, it pins down its victim. With precision, it sinks its saber teeth into the prey's soft underbelly, causing massive internal damage and blood loss. But not everyone buys this gut-stabbing hypothesis. Many researchers favor a different, but equally grim, scenario. They propose that Smilodon used its powerful build to quickly overpower its prey, then delivered a precise lethal bite to the throat. This would have caused severe blood loss and suffocation. A quick, if not particularly pleasant end for its unfortunate victims. Adding fuel to this theory is the discovery that Smilodon could open its jaw to an incredible 120 degrees, almost twice as wide as a human can manage. With a gape like that, pretty much every neck in the Ice Age would have been fair game. But Smilodon wasn't just brawn and teeth. Brain scans of Smilodon skulls suggest that these prehistoric predators had excellent coordination, sharp hearing, and top-notch vision. Their eye socket shape hints at binocular vision, giving them the depth perception needed to judge distances accurately, crucial for a predator that relied on ambush tactics. And if all that wasn't enough, they were fast too. Many Smilodon fossils show trauma to their sternums, the kind of injury you'd expect from high-speed collisions. This suggests that not only were they quick on their feet, but they were also willing to risk life and limb, or at least a bruised chest, in pursuit of their next meal. Smilodon's unique traits, along with its powerful weaponry, made it a versatile hunter capable of taking down a wide variety of megafaunal prey. The specific animals it targeted varied based on the region it called home. In North America, their prey included oversized versions of animals we recognize today, giant bison, camels, and, if the opportunity arose, even mastodons and Columbian mammoths. Yes, these cats were taking down creatures that dwarfed modern elephants. In South America, Smilodon's targets were equally impressive and diverse, including creatures like Toxodon, Litopterna, various species of Glyptodont, along with more familiar animals such as horses and camelids. Some evidence even suggests that Smilodon occasionally went after caimans, cementing its status as a top predator. We know what Smilodon ate thanks to skeletal evidence, such as tooth marks on bones, or Smilodon remains found alongside those of their prey, providing vital clues about its diet. One big question that's still hotly debated in paleontology circles is whether Smilodon was a lone hunter or a team player. This isn't just academic curiosity. Knowing whether Smilodon hunted in packs could tell us a lot about its social structure and what kind of prey it typically targeted. And Smilodon, the saber-toothed cat, wasn't the only predator with an appetite for mammoth-sized meals. Two of its biggest rivals were the American lion and the dire wolf. It's a testament to the sheer scale of life in that era. There's something rather touching about the idea that these fierce cats cared for their own. Some evidence suggests that injured Smilons were supported by their fellow cats, much like modern lions or wolves might support injured members of their pride or pack. There's a Smilon fossil that shows signs of hip dysplasia from a young age, yet it managed to survive to adulthood. It's hard to imagine how such an animal could have hunted successfully on its own. It leads to this heartwarming, if speculative, image of Smilodon families looking after their own. Of course, not everyone's convinced by the Smilon social club theory. Some researchers point out that Smilon remains found outside of predator traps tend to be more isolated. They argue that this suggests a more solitary lifestyle, more in line with many modern big cats. Regardless of whether Smilodon was a team player or a loner, one thing's for it was at the top of the food chain. But that doesn't mean it didn't have competition. Now, if you're picturing the dire wolves from Game of Thrones, it's worth noting that while real dire wolves were impressive, they weren't quite as monstrous as their fictional counterparts. But they were formidable predators in their own right. Isotope analysis shows that they had a diet very similar to Smilians. In other words, these predators were often competing for the same prey. So, how did Smilodon stack up against its competitors? Well, when it came to the American lion, it was probably a bit of a standoff. The American lion had size on its side, being one of the largest cats to ever exist. But Smilodon had those impressive canines, which likely served as a pretty effective deterrent. Most likely, these two apex predators tried to avoid each other when possible, but when conflicts did occur, it could have gone either way. The dire wolf, on the other hand, seems to have often come out second best in confrontations with Smilodon. Evidence from Labra suggests that dire wolves would frequently abandon their kills when a Smilodon showed up. It's not hard to imagine why, given those sabers being on full display all the time. Most predators probably decided that discretion was the better part of valor. But lions and wolves weren't the only competition Smilodon had to worry about. The Ice Age was also the time of the short-faced bear, a beast that could make even Smilodon look small by comparison. Some of these bears reached truly dinosaurian proportions, rivaling medium-sized sauropods in weight. However, these ursine giants were more omnivorous than Smilodon, which likely reduced direct competition. Plus, bears tend to be solitary creatures. So, if a group of Smilodons encountered one, the bear would likely have decided that this particular picnic basket wasn't worth the trouble. We've talked a lot about Smilodon's impressive hunting adaptations, but there's one question we haven't addressed yet. How on earth did it eat with those ridiculous teeth? After all, those saber-like fangs seem like they would have been quite the obstacle during feeding. Well, Smilodon had a solution for that too. Unlike most predators that can chomp down from the front, Smilodon was equipped with specialized slicing teeth called carnassials. These teeth, situated on the sides of the mouth, worked like biological scissors, shearing through meat with ease. To eat, Smilodon would have turned its head to the side, using these carnassials to slice off manageable chunks of meat while its saber teeth stayed out of the way. If this eating style sounds familiar, that's because you might have seen it in action. Many modern cats and even other predators use a similar technique when tackling tough pieces of meat. It's a prime example of nature's problem solving. When life gives you saber teeth, you adapt your eating style accordingly. With its unique adaptations and hunting prowess, Smilodon carved out a vast empire for itself. Between its three species, it achieved a distribution across the Western Hemisphere that would make any modern predator grin with envy. In North America, Ezralis and Esfatalis roamed from coast to coast, reaching as far north as Alberta, Canada. Meanwhile, in South America, Esfatalis and Espopulator established a domain stretching all the way down to Patagonia. But Smilodon wasn't just geographically widespread. It was also adaptable. Fossils have been found in a diverse array of environments, from grasslands and plains to woodlands and closed forests, from savas to subtropical forests, and even mammoth steppes. This adaptability allowed Smilodon to live alongside a veritable who's who of Pletwine megapona. We're talking about a world where you might encounter short-faced bears, proboscideans, ground sloths the size of cars, armored gypodons, the rhino-like toxodon, camels, deer, horses, bison, and even terror birds. It was like a real-life version of the ice levels in every video game, but with 100% more lethal prehistoric cats. But there was one more species that Smilodon encountered in its twilight years. One that would change the face of the planet forever. Humans. It's believed that our ancestors might have first crossed paths with Smilodon around 25,000 years ago. Now, imagine being one of those early humans, armed with nothing but primitive tools, coming face to face with a saber-toothed cat. The relationship between humans and Smilodon was likely a tense one. After all, we were competing for many of the same food sources. And unfortunately for our ancestors, by the time humans arrived on the scene, only the largest populator and Aspatilus remained. Talk about bad timing. Given that Meganterion, the possible predecessor of Smilodon, was known to occasionally prey on Homo erectus, it's not a stretch to imagine that Smilodon might have considered early humans as potential prey too. But don't feel too bad for our ancestors. Humans are nothing if... I find myself often thinking about the extinction of the Smilodon, the saber-toothed cat. It's a story that resonates deeply, a reminder of how even the most magnificent creatures can disappear. The youngest remains we've found date back about 10,000 years, around the time humans were developing agriculture. The reasons for their extinction are still debated, of course. Some believe humans played a role, either through competition or habitat alteration. But the more widely accepted theory points to the Quaternary extinction event, a period of significant climate change that wiped out many large animal species in North and South America. As the megafauna that Smilodon relied on for food disappeared, so did the great cat. It was too specialized, too good at hunting large prey, and it couldn't adapt when its world changed. Its passing marked the end of an era, the last of the saber-toothed cats. The Smilodon's legacy remains, though, in museum exhibits, in our imaginations, and as a stark reminder of the delicate balance between species and their environments. As we face our own period of rapid change, the lesson of the Smilodon is clear. Survival requires adaptation. Most apex predators face a fundamental limitation. They're trapped in one environment. Lions rule the savanna but are helpless in water. Great whites dominate the ocean but can't set a fin on land. Even T-Rex was confined to dry ground. But then came Spinosaurus aegyptiacus. Longer than a bus, with the skull of a crocodile and the body of an aquatic hunter, it redefined what it meant to be an apex predator. What unsettles me most about Spinosaurus isn't its size, though at 50 to 59 feet, it dwarfed even the largest T-Rex. It's not even the massive sail rising from its back. No, it's how perfectly wrong everything about this creature seems, and yet how devastatingly effective each bizarre feature proved to be. Take that skull, a narrow, elongated nightmare stretching nearly 6 feet long. If you've ever stared into the eyes of a large crocodile, you understand the primal fear that comes from seeing a predator perfectly designed for aquatic ambush. Now imagine that same sinister profile scaled up, mounted on a body that could rear up 20 feet into the air. The skull alone weighed as much as a small car. Yet it cut through water with the efficiency of a torpedo. Picture this nightmare rising from murky water. First, the elongated snout breaking the surface, then those cold reptilian eyes, and finally, that towering sail cutting through the air like the dorsal fin of some impossible shark. Imagine the terror of being a fish in the rivers of Cretaceous Africa. Your entire lineage has adapted to recognize danger. The shadow of a pterosaur overhead, the ripples of an approaching crocodile, the subtle current shifts that signal a nearby predator. Every instinct is tuned to read these watery warning signs, sharpened by countless generations of survival. And then Spinosaurus arrived. That massive dorsal structure wasn't just for show. When Spinosaurus needed to move through areas where full swimming wasn't possible, it acted like the keel of a boat, providing stability and control, even in water too shallow for other large predators to navigate effectively. Even at 7 tons, it possessed the mass to overpower virtually any prey, yet remained streamlined enough to move through water with deadly grace. Modern great white sharks inspire fear because they embody millions of years of mastery in aquatic predation. But Spinosaurus had even longer to sharpen the same deadly craft, only with added intelligence, versatility, and sheer size that dwarfs any marine predator alive today. It transformed every waterway it entered into its personal killing field. The attack began before you even realized you were being hunted. Every animal in Cretaceous Africa needed to approach rivers and lakes regularly to survive. For millions of years, this had been a calculated risk. Stay alert, drink quickly, watch for crocodiles. Suddenly, the riverbank itself became unreliable. That submerged log might be a 50-foot predator. Those ripples might not indicate current or wind, but the approach of something that could strike from below with the force of a freight train. The fossil evidence suggests Spinosaurus didn't just occasionally venture into water. It lived there. This wasn't a terrestrial predator that sometimes waded into rivers for a quick meal. This was a creature so perfectly adapted to aquatic life that it spent most of its time submerged, transforming ancient waterways into hunting territories more dangerous than any terrestrial predator could create. In a world where survival depended on understanding and avoiding threats, Spinosaurus represented something unprecedented. A predator that eliminated the fundamental distinction between land and water safety. It didn't just dominate 2 worlds, it merged them into a single inescapable killing field. And Lee, we can't be talking about the perfect killing machine without mentioning its teeth. Conical, dagger-like, and built to clamp down on prey that thought the water would save them. Each one wasn't just for piercing. It was angled backward like barbed hooks, creating a living fish trap built on a terrifying principle: easy entry, impossible exit. I find myself haunted by the thought of a world where death could strike from any angle, at any moment. That's the world Spinosaurus created. It wasn't just a predator. It was a perpetual killing machine, turning waterways into active crime scenes. Imagine a lush river system snaking across North Africa, a prehistoric paradise teeming with life and unimaginable danger. We call it the Kelenken Beds Formation. Picture rivers deeper and wider than the Amazon, tropical forests stretching to the horizon, and the air alive with the calls of creatures that would dwarf modern elephants. In this steaming, river-choked ecosystem, Spinosaurus was far from alone. It shared its territory with a deadly mix of predators, prey, and rivals. Giants like Carcharodontosaurus patrolled the inland areas, while Sarasuchus, the 40-foot supercroc, competed directly for aquatic hunting grounds. Mid-sized hunters cleaned up Spinosaurus's leftovers, and swift predators used speed and specialized tactics to carve out their place. Even the herbivores faced a gauntlet of dangers just to survive. Every species lived in constant tension with Spinosaurus's dominance. Land predators maintained uneasy truces. Herbivores relied on elaborate survival tactics just to drink, and aquatic prey developed increasingly tough defenses. While obviously from a large carnivore provided only hints of the creature's true nature, the jaw's wolf-like characteristics led early paleontologists to classify it as a subgenus of Canis, the genus that includes modern wolves, coyotes, and jackals. This classification seemed logical at the time given the limited fossil evidence. However, as more complete specimens emerged from North American fossil beds throughout the following decades, a much more complex picture began to emerge. The discovery of complete skulls proved particularly revolutionary. These specimens revealed that while certain features resembled those of wolves, others were startlingly different. The skull. It was like nothing I'd ever seen. It possessed these specialized enlarged premolars and this unbelievably robust cranial structure. It looked more like something from a lion or hyena than any dog I knew. When I first saw it, I couldn't help but wonder, what was this creature? The answer, as it often does, lay in the details. Those unique premolars, that powerful jaw, they pointed directly to the Borophaginae subfamily. This group, a distinct branch within the larger canid family, represents one of the most successful, yet strangely overlooked chapters in canine evolution. The Borophaginae were remarkably diverse, boasting 66 known species. They were defined by their powerful teeth, short but deep jaws, and a fifth toe, a feature lost in many modern canids. For over 15 million years, they dominated North America, evolving into an array of forms. Some were no bigger than foxes, while others rivaled the size of today's grey wolves. And then there was Apicion, the ultimate expression of this bone-crushing lineage. Its name literally translates to more than a dog. Recent studies of modern canids have really helped us place Apicion within the family tree. The Borophaginae, it seems, were a highly specialized branch, a unique path diverging from the lineage that led to modern wolves and dogs. This specialization explains both Epicion's unusual features and, ultimately, its fate. Within the Epicion genus, 3 distinct species emerged to fill different ecological niches: Epicion saevus, Epicion haydeni, and Epicion elodontoides, all impressive predators, but varying in size and build. The smaller species, saevus and elodontoides, were still formidable, but possessed more gracile builds, allowing for greater agility and speed. Even these smaller species, though, typically weighed twice as much as a modern German shepherd. But it was Epicion haydeni that truly pushed the boundaries of canid adaptation. Recent studies of well-preserved specimens have revealed truly impressive dimensions. Adults routinely reached lengths of 2.4 meters, nearly 8 feet, rivaling a grizzly bear. They stood 90 centimeters, or 35 inches, at the shoulder, comparable to a wild deer. This massive frame supported an equally impressive body mass. The mechanical advantage of this dental arrangement wasn't just theoretical either. Microscopic analysis of wear patterns on preserved teeth provides direct evidence of how Epicyon used its formidable bite in real-world situations. These studies show distinctive patterns of wear consistent with both flesh slicing and bone crushing activities, suggesting a predator that could efficiently process every part of its prey. Evidence from fossil deposits indicates that Epicyon was an opportunistic predator capable of taking down a wide range of prey. Their fossil remains have been found in association with various prey species, including ancient camels, pronghorns, horses, and peccaries. Perhaps most impressively, they appear to have been capable of hunting prehistoric rhinoceros species like Teleoceros, which could reach lengths of 4 meters and weigh nearly 2 tons. Recent studies suggest that Epicyon may have employed different hunting strategies depending on prey size and availability. For smaller prey, they likely hunted alone or in pairs, using their impressive speed and power to quickly overwhelm victims. However, evidence increasingly points to the possibility that they also engaged in pack hunting, particularly when targeting larger prey. This hypothesis of social hunting behavior is supported by multiple lines of evidence. This sturdy build, while potentially limiting their agility and endurance compared to modern wolves, would have been advantageous in close-quarter combat with large prey. Recent studies of their limb proportions suggest they were built for powerful, explosive movements rather than long-distance pursuit. This adaptation indicates they likely relied on ambush tactics or short, high-speed chases, rather than the endurance hunting strategy employed by modern wolves. In this context, pack hunting would have been particularly advantageous, allowing groups to surround and overwhelm prey that might have otherwise escaped a solitary hunter. One of Epicyon's most remarkable adaptations was its ability to process and digest bone, a trait that set it apart from most other large carnivores. Its specialized premolars and thickened molars, characterized by their short, pyramid-like shape and wide bases, closely resembled those of modern hyenas. This similarity represents a fascinating example of unrelated species developing similar adaptations to exploit the same ecological niche. Recent analysis of fossilized feces associated with Epicyon has revealed high concentrations of processed bone material, confirming their bone-crushing behavior. This adaptation would have provided several advantages. First, it allowed them to extract maximum nutrition from their kills by accessing bone marrow, one of the most nutrient-rich tissues available to carnivores. Second, it potentially reduced competition with other predators by allowing them to utilize parts of carcasses that other carnivores couldn't process. This ability to process bone would have been particularly valuable during periods of scarcity. The Miocene epoch was characterized by significant climate fluctuations, with periods of both warming and cooling, and shifts between wet and dry conditions. During times when prey was scarce, the ability to fully utilize every part of a carcass, including the bones, would have provided a crucial survival advantage. The success of Epicyon is evident in its widespread distribution across North America during the Miocene. Fossil remains have been discovered in more than 10 different US states and parts of southern Canada, indicating a remarkable ability to adapt to various environments. Recent paleo-environmental studies have shown that these ancient predators thrived in a diverse array of habitats, from woodlands and savannas to grasslands and wetlands. Particularly interesting are recent discoveries of epicyon remains in cave systems and edge environments, areas where different habitat types intersect. These findings suggest that epicyon was not only adaptable, but potentially strategic in its habitat selection, preferring areas that provided both hunting opportunities and shelter. Their ability to process a variety of foods likely contributed to this ecological flexibility. While primarily carnivorous, the structure of their teeth suggests they could also process tough plant material when necessary. This dietary flexibility, combined with their bone-crushing abilities, would have allowed them to survive in a wide range of environments and through various seasonal changes. The ultimate disappearance of epicyon from the fossil record has long intrigued paleontologists. Early theories suggested that competition from newly arriving big cats led to their extinction. However, this hypothesis has largely been discounted, as many of the large cats that would have competed with epicyon, such as the famous Smilodon, didn't appear in North America until millions of years after epicyon's disappearance. Current evidence points to climate change as the primary driver of epicyon's extinction. The late Miocene saw significant global cooling and increased aridity, leading to fundamental changes in North American ecosystems. Recent paleobotanical studies indicate a shift from mixed woodland savanna environments to more open grasslands. This transformation would have affected not only the types of prey available, but also hunting strategies. Epicyon's specialized adaptations, its heavy build, bone-crushing teeth, and relatively short legs may have become disadvantageous as prey species became faster and more adapted to open environments. It was clear this discovery would our understanding of dinosaur defense mechanisms. The name itself tells a story. Ankylosaurus, meaning fuse lizard, refers to its remarkably fortified skeleton, while magnaventris translates to great belly, highlighting its distinctively broad midsection. This unique combination of features demanded its own taxonomic family. In 1906, Barnum Brown, a renowned paleontologist from the American Museum of Natural History, led an expedition through Montana's Hell Creek Formation. Among the layers of Cretaceous sediment, Brown unearthed an assortment of fossils that initially perplexed him. These weren't the slender bones of theropods or the broad frills of ceratopsians. Instead, he'd uncovered fragments of bony plates, uniquely shaped teeth, and vertebrae that hinted at a heavily armored animal. Early interpretations were cautious. Brown speculated that the bones might belong to a previously unknown type of armored dinosaur. Over time, further excavations in Canada and the western United States revealed more specimens, each shedding light on the creature's physical characteristics. The painstaking process of piecing together its skeletal framework was like assembling a prehistoric jigsaw puzzle, with every discovery adding a layer of complexity to its story. What made Ankylosaurus magnaventris stand out was not only its robust anatomy, but also its ecological implications. Modern engineering analysis has given us even more insights into this remarkable defense system. Beneath those armored plates, there was a network of collagen fibers that puts modern protective materials to shame. These fibers, significantly thicker than those found in modern armored animals like crocodiles and armadillos, created a natural composite material similar to modern fiber-reinforced plastics. Recent biomechanical studies have shown that this combination of hard plates and flexible fibers could absorb and dissipate energy from impacts in ways that purely rigid armor couldn't match. In fact, when subjected to simulated impact tests, reconstructions of Ankylosaurus armor proved capable of withstanding forces that would have seriously injured or killed most other dinosaurs. But perhaps the most fascinating aspect of the Ankylosaurus's defensive arsenal was its legendary tail club. This wasn't just a simple bony growth. It was a precisely engineered weapon system that represented one of nature's most effective deterrents against predation. Recent CT scanning of tail club fossils has revealed an intricate internal structure that optimized the club for both strength and swing speed. The club itself was composed of two large osteoderms at its core, complemented by smaller ones at the tip and along the midline, all supported by a framework of highly modified vertebrae that was specifically adapted to handle the stresses of high-speed impacts. The mements are staggering. Specimens show the club could reach 57 centimeters or 22.5 inches in width and weighed approximately 23 kilo or 50 lb. But these numbers only tell part of the story. The real marvel was in the biomechanics. Advanced computer modeling has shown that large individuals could generate impact forces exceeding 20,000 newtons, and even more remarkably, could achieve swing impulses of up to 4,800 newtons per second. To put this in perspective, while a professional baseball player generates about 13 newtons per second in their swing, the Ankylosaurus's tail strike was 370 times more powerful. Recent studies using finite element analysis have even suggested that the impact force could have been focused on an area as small as a few square centimeters, multiplying its bone-crushing potential. The behavior and lifestyle of Ankylosaurus were as unique as its anatomy. While much of its life remains a mystery, fossil evidence offers glimpses into its daily routines and survival strategies. Juvenile Ankylosaurus specimens, for example, lacked the fully developed armor and tail clubs seen in adults. This vulnerability likely necessitated group behavior during the early stages of life. Trackway fossils suggest juveniles may have formed protective herds, with larger individuals shielding the more vulnerable young in the center, a defensive strategy reminiscent of modern musk oxen. As they matured, Ankylosaurus individuals underwent significant lifestyle changes. Even its teeth offer a glimpse into a world so different from our own. Recent studies suggest that while this herbivore primarily grazed on ferns and horsetails, it might have occasionally supplemented its diet with fungi or small invertebrates. I find that fascinating. This unexpected flexibility in a creature so seemingly fixed in its habits. It reminds me of how even the most dedicated scholars sometimes stumble upon new perspectives, enriching their understanding. The Ankylosaurus, it seems, possessed a complex digestive system, a veritable fermentation factory housed within its broad midsection. Fossilized remains hint at symbiotic gut bacteria, tiny allies crucial for breaking down tough cellulose. I imagine this internal ecosystem, a hidden world working tirelessly to sustain such a massive body. Its sense of smell, too, was remarkable, perhaps even surpassing that of modern reptiles. Intricate nasal passages not only enhanced its ability to detect food and predators, but also aided in regulating its body temperature. It paints a picture of a creature finely attuned to its environment, its senses and defenses working in perfect harmony. I'm particularly drawn to the idea of how the Ankylosaurus might have used its senses in tandem with its armored defenses. Detecting a predator early allowed it to strategically position itself, presenting its formidable tail club. It's a testament to the power of sensory awareness in the face of danger. The Ankylosaurus eventually disappeared, along with the other non-avian dinosaurs, during the KT extinction event around 66 million years ago. Yet, its legacy endures, offering insights into natural design and defense mechanisms. The Cretaceous period was a time of titans, a stage for not only the largest terrestrial predators, but also the largest land animals ever known. But dinosaurs weren't the only giants. Around 82 million years ago, North America saw the rise of Deinosuchus, the largest crocodilian in Earth's history. Its name, terrible crocodile, is fitting. Discovered in the 1850s, its massive teeth were initially mistaken for those of a marine reptile, causing quite the stir among paleontologists. When I first encountered the story of Deinosuchus, I was struck by the sheer scale of the creature. Imagine a crocodilian that could reach nearly 50 feet in length and weigh over 10 tons. The initial claims seemed almost unbelievable, but the more I dug into the research, the more I realized that these exaggerated estimates weren't that far off. This wasn't some case of shrinking fossils. Deinosuchus truly was a colossal beast. There are 3 recognized species of Deinosuchus. There's Hatcheri, rugosus, and riograndensis. The Hatcheri species, found in North Carolina, was one of the first identified, offering crucial insights into the genus's structure and lifestyle. Then there's the rugosus species, primarily discovered in Montana. His research revealed that the largest specimens exhibited growth rings in their osteoderms, similar to tree rings, which offered valuable information about their age and growth rates. Notably, some of the largest riograndensis individuals showed evidence of rapid growth spurts during their juvenile years, followed by more gradual growth into adulthood. These findings underscore the significant impact of environmental factors, such as food availability and climate conditions, on the growth and maximum size of Deinosuchus. With its brain case and overall appearance, Deinosuchus bore a striking resemblance to modern alligators, including a body and snout that superficially mimicked these contemporary relatives. This similarity made Deinosuchus an imposing figure in its environment. However, beyond this general resemblance, Deinosuchus was distinct from other crocodilians, featuring a unique skull shape not seen in any living or extinct genus. The skull of Deinosuchus was exceptionally large, measuring up to 5.6 feet in length, comparable to that of an adult Spinosaurus. Despite its impressive size and robust build, studies have shown that Deinosuchus's bite force was somewhat surprisingly modest. A 2002 study reported a bite force of about 18,000 newtons, sufficient to crush bones, but relatively weak considering its size, especially when compared to the smaller saltwater crocodile, which exerts a bite force of 16,500 newtons. Examinations of Deinosuchus fossils reveal that its skull was not only massive, but also highly specialized. The arrangement of its teeth showcased a combination adapted to its predatory lifestyle: conical and sharp front teeth for grasping prey, and blunt, robust rear teeth designed for crushing bones. This unique dental structure allowed Deinosuchus to tackle a diverse range of prey, from large dinosaurs to hard-shelled turtles, highlighting its versatility as a formidable predator. The bite force of Deinosuchus has been a topic of considerable debate and study, reflecting one of the widest ranges in estimates for any prehistoric predator. Initial research suggested a bite force of around 18,000 newtons, a figure based on the size and structure of its skull. However, this estimate was challenged by a later study, which proposed that Deinosuchus possessed an astonishingly powerful bite force exceeding 100,000 newtons, nearly double that of Tyrannosaurus rex. This dramatic discrepancy highlights the ongoing debate within the paleontological community. Dr. Greg Erickson, leading one of the key studies on this topic, employed advanced biomechanical modeling to simulate Deinosuchus's bite mechanics. Erickson's team found that the robust construction of Deinosuchus's skull and teeth supported the possibility of such a formidable bite force. With 22 exceptionally robust teeth designed to withstand high forces, and some specifically adapted for crushing large bones, this ancient crocodilian was well equipped to exert tremendous press. The latest evidence leans towards the higher end of the estimated range, reinforcing the notion that Deinosuchus could have indeed possessed one of the most powerful bites of any known predator. This higher estimate aligns with the physical characteristics of its skull and teeth, suggesting that Deinosuchus was capable of generating extreme biting forces, making it one of the most formidable crocodile forms ever to have existed. The formidable bite force of Deinosuchus, along with its durable and sizable teeth, about the size of a banana, points to its role as a dominant predator of its time. This prehistoric giant was well equipped to tackle the largest prey in its environment. Evidence suggests that Deinosuchus primarily targeted large. Imagine the terror of a duck-billed dinosaur, a Griosaurus or Chasmosaurus, suddenly feeling the crushing bite of Deinosuchus. We know from fossilized tail vertebrae found in Texas that this ancient crocodile didn't just graze on seaweed. The bite marks tell a brutal story. Deinosuchus. Its size and strength made it a threat to nearly every other dinosaur in its territory, even large theropods like Apalachiosaurus. Bite marks don't lie. Deinosuchus influenced the size and distribution of other predators simply by being the biggest and baddest. It inhabited diverse environments: estuaries, freshwater lakes, rivers, and possibly even deeper marine waters, though some believe those remains might have been displaced after death. Still, its adaptability is clear. Its strong limbs and tail allowed it to navigate both aquatic and terrestrial settings, tolerating varying salinity levels. If Deinosuchus did venture into deeper waters, it might have encountered other giant predators like Tylosaurus, one of the largest mosasaurs. That's a predator-prey dynamic I would have loved to witness. Deinosuchus lived alongside a vast array of dinosaurs and other prehistoric creatures, including herbivorous dinosaurs like Anodontosaurus, Gryosaurus, and Cosmoceratops. Bite marks on the bones of hadrosaurs and other dinosaurs are a grim reminder of its predatory prowess. Deinosuchus's presence likely impacted the distribution and behavior of these animals, establishing itself as the apex predator. Yet, despite its dominance, Deinosuchus vanished from the fossil record around 73 million years ago. The reasons for its extinction remain unclear, but climate changes, sea level fluctuations, and competition with emerging predators are all potential factors. Its extinction marked the end of an era. Then, thinking about apex predators in general, my mind wanders to the world of big cats. The tiger, lion, and jaguar have always fought for supremacy, each vying to be the ultimate hunter. I remember being stunned when I first read about the grey wolf fossil, the one with its femur completely severed by a single bite. The wolf survived, incredibly, but the image of that power has always stuck with me. Nearly 3 times stronger than a modern lion, 6 times more powerful than a smilodon. That's what they say. And beyond brute strength, there's the question of their intelligence. A notably large brain case, suggesting cognitive capabilities that went beyond simple instinct. I find it fascinating that, despite being common, their remains are underrepresented in tar pits. Were they simply smarter, more aware of their surroundings than the dire wolves and smilodon? It seems likely. They roamed from Alaska to central Mexico, these magnificent creatures, sharing the land with mammoths, mastodons, and early humans. I often wonder what those interactions were like, if the cave paintings truly captured the impact they had on early American cultures. And then, about 12,877 years ago, they were gone. Climate change, human expansion, a combination of factors, no doubt, pushing them past the brink. But as one great hunter vanished from the skies, another arose. I'm thinking now of Quetzalcoatlus, the immense pterosaur that soared over the land with what must have seemed like an iron fist. Imagine the shadow of those massive wings, causing panic below as potential prey scattered, desperate for cover. Others suggest it lurched forward on its wingtips, like a vampire bat, or even crouched and launched itself several feet into the air to gain enough space to spread its wings. Its strong hind legs would have been crucial for this massive push. One study suggested Quetzalcoatlus was a remarkable flyer, engaging in brief powered flights before gliding, reaching speeds of up to 80 meters/minute. They could potentially sustain this for days, giving them an extraordinary range. Despite its size, its torso was incredibly dense, packed with massive muscles. A single leap and a few flaps might have been all it needed to take off and maintain altitude. After launching, it could probably fly non-stop for 16,000 kilometers, flapping rarely to maintain altitude and guide its course. Its short wings, made of tightly packed muscle fibers, end flexibility and strength, allowing for precise adjustments in the air. The extraordinary flight techniques of Quetzalcoatlus even inspired a Johnson Wax-sponsored mission to construct a model flying machine to test flight simulations. About the size of Quetzalcoatlus lawsoni, with a basic computer acting as an autopilot. The model demonstrated the effectiveness of the experiment by soaring and flapping its wings as it went through the air. It's now thought that Quetzalcoatlus and other agile had hind limb proportions more similar to modern running mammals, suggesting they were uniquely suited to a terrestrial lifestyle, even though they were quadrupeds on the ground. It's widely accepted that Quetzalcoatlus was a carnivore, though its exact diet has been debated. Douglas Lawson, who first discovered Quetzalcoatlus, initially thought it scavenged on the carcasses of titanosaur sauropods, much like a marabou stork. He believed scavenging was the only option because the fossil was located far from the coast, with no signs of large rivers or deep lakes nearby. But this scavenging idea was later debunked. Scientists pointed out that unlike the hooked beaks of specialist scavenger birds, Quetzalcoatlus had a lower jaw that bent steeply downward, leaving a gap between it and the upper jaw even when fully closed. Another idea suggested it ate like modern skimmers, cleaving the waves with its beak and grabbing fish mid-air. However, this skimming theory was also challenged. Studies showed that the energy requirements for skimming would be too great for such a massive creature. Furthermore, the skeletal structure wasn't suited for that kind of feeding. Skimmers have necks designed to absorb sudden impacts, but Quetzalcoatlus lacked these adaptations. Instead, its anatomy is more similar to modern storks, suggesting it likely pursued and hunted small animals on land. We are starting to learn more about the habitat of this unique creature that once ruled the skies of the late Cretaceous Maastrichtian age of North America. Quetzalcoatlus most likely lived in a variety of settings during the late Cretaceous period, including coastal regions and inland plains. These enormous landscapes. The idea that I might have walked the earth alongside a Tyrannosaurus rex is almost too much to take in. To imagine these giants sharing the same space, the same sky, it changes everything. Quetzalcoatlus, you see, wasn't alone. Fossils suggest that creatures akin to the T-Rex and Torosaurus may have coexisted with it, though more studies are needed before we can say for this flying giant likely shared its domain with other pterosaurs, such as Pteranodon and Nyctosaurus, all existing within these vanished ecosystems. I picture Quetzalcoatlus hunting, nesting, and roosting, perhaps even in different ways depending on the specific species. One, Elson might have lived in swarms near alkaline lakes, a sociable sort, while Quetzalcoatlus norupi was likely a solitary hunter, roaming freely inland. And alongside the Alamosaurus, Quetzalcoatlus may have crossed paths with other herbivorous giants and fearsome predators, like the T-Rex, Dromaeosaurus, Triceratops, Albertosaurus, Edmontosaurus, and Dakota. I must admit, the thought of encountering such colossal creatures, Quetzalcoatlus included, does make me grateful to live in a time beyond their reign.